The objective of this module is to create an API gateway for Amazon Web Services, one that employs an existing backend or set of microservices. This gateway will allow us to make changes to requests before they reach the service or microservice provider, and potentially reroute requests to new versions of the services as they become available without having to notify the user. With regard to knowledge requirements, you will have to have some familiarity with Amazon Web Services. As usual, this video is divided into subsections indicated by the labels at the bottom of the screen. This allows you to manually navigate the lecture as you need. You have been provided a folder with several supplemental resources that you can download and use. The main resource for this project is named resource.11.07. It contains the Open API source code. However, we will highlight others during the lecture with similar label structures. I hope you will consider joining my mailing list. No spam, just updates and corrections to lectures. Link to subscribe is on the screen. Also, please consider subscribing to my YouTube channel. Tons of free lectures. That link is also going to be on the screen right now. Now let's talk about the parts of this module. What topics are we going to discuss? The first couple are background. Background on API gateways. Background on representational state transfer. Background on RESTful APIs. Background on the Hypertext Transfer Protocol, and most importantly, background on the Open API specification. This is the main framework we're going to be using to develop and design our API gateway. Then we jump into the steps of the example. There's 4. The first is to define the objectives and the methods of our gateway. The second is to access the REST API gateway service on AWS and import the example code. The third is to review the API source code within the Open API framework. So we're going to go through that, not line by line, but we are going to highlight the most important parts of the code, and we're going to really do a deep dive and try to explain this in greater detail to all of you. And then the last step is going to be to import, execute, and test our example. So let's begin by talking about API gateways and how they allow us to build upon the capabilities of pre-existing APIs. One structure that we must become familiar with is the API gateway. We've already discussed what an application programming interface API is, so no need to discuss that again. But what is an API gateway? It's a management tool that sits between the client and a collection of backend services, like microservices. Quick note, you can check out resource.11.01 here for some additional background. So let's say you want to create a new API composed of existing microservices hosted by different cloud providers, and those could be in several different locations. This is less than optimal. It may be confusing to clients attempting to call these API services. One potential solution is to develop an API gateway, a single web object that does several different things, and I'm going to list those here. So it accepts a variety of API requests, regardless of where the target services are actually hosted. It contains a mapping of requests and how they should be mapped or routed to the microservice providers. For example, request A needs to be routed to microservice B on Microsoft Azure. I just, made that up. While request C needs to be routed to a microservice hosted by a private machine at an IP address XYZ. Okay, so essentially it stores a record of how different requests need to be routed to different services or service providers. So those are 2 bullets. A third is it manages any changes to the request format required by any potential client or service that interacts with the gateway. So let's say, for example, there's a little bit of a mismatch between how our client wants to supply the request and how our service wants to accept it. A gateway in the middle can provide that translation capability. It also enforces throttling and security policies, and it facilitates, and this is really a catch-all, it facilitates two-way communication between various clients and services while appearing as a single web resource. In this module, we are going to examine the development of an API gateway. Before we jump into the example or the steps of the example, let's do a little bit more background. The next topic I want to discuss is representational state transfer, or the REST architectural style. This architectural style facilitates communication between a variety of unrelated internet-connected devices. In a RESTful web service, requests do three different things. They target a resource's universal resource identifier, URI, number one. Number two, they carry a payload formatted as HTML, XML, JSON, JavaScript object notation, or a similar format. And then third, they elicit a response from the resource or from the service. One may think that this is the same as an HTTP request because we're talking about a lot of the same structure and a lot of the same keywords. We're going to use get, post, etc. And this is not completely unfounded. HTTP is a protocol that tries, for the most part, to adhere to the RESTful architectural style. When HTTP is used to communicate a RESTful request, the following operations or commands are available. They're listed right here. We have get, which is used to retrieve information, post, which is primarily used to create child resources, put, which is primarily used to update existing resources. And although it's not recommended, it can also be used to create child resources. Then we have delete, which, as the name suggests, is used to delete resources. The last three, patch, head, and options, I'm not going to go over in detail right now. You can read the descriptions. They're more likely to be used in testing scenarios. Test, test, test. The next section is background on RESTful APIs, obviously a related topic. A RESTful API is one that adheres to the rules that we talked about just a second ago. Generally, they are composed of the following pieces. We have a base URL or URI, a universal resource locator or universal resource indicator, and such an example would be the HTTP address shown right here. This indicates where the service provider is located. Second, we have the HTTP method type, and we just talked about these a second ago right here. Examples include get, post, put, etc. Third, we have the media type. This defines the state transition elements. Examples could be JSON objects. It could be as simple as a URL or as complex as a Java applet. The get method is what we call a safe method or nullipotent. Again, I apologize for the pronunciation here. This means that calling it produces no side effects. Retrieving or accessing a record does not change it. We know this as a characteristic of the get method. The put and delete methods are what we call idempotent. Again, I'm not sure if the pronunciation is correct. Meaning that the state of the system exposed by the API is unchanged, no matter how many times, more than once, the same request is repeated. So essentially, if you call put once, and then you call put again a third time, it's the same action happening over and over. You're not going to have 2, 3, 4, or 5 copies of this entry. Same thing with delete. If you call delete for a certain object more than once, it will simply cause no change. Unlike SOAP-based web services, there is no official standard for RESTful APIs. This is because REST is an architectural style, while SOAP is a protocol. So SOAP is more formalized than REST, which is a more relaxed sort of general guideline on how these requests should be structured. REST describes a set of rules based on HTTP, JSON, URI, and XML standards. RESTful description languages. There are many languages that may be used to describe a RESTful service, including the Web Services Description Language and Open API Specification. That's what we're going to use in this example. Check out resource 11.01b if you want more background on that. The next topic is Hypertext Transfer Protocol. We've already talked about Hypertext Transfer Protocol. However, we provide a bit more of a robust review here. HTTP is an application protocol for distributed, collaborative, and hypermedia information systems. I think you are all very familiar with it. It adheres to the rules outlined generally by the REST architectural style, functioning as a request-response protocol where the client submits an HTTP request message to a server, and that server returns a response message to the client. As referenced above, the HTTP protocol defines the methods of get, head, post, put. We already listed all those a second ago. Now moving on to the request message format. An HTTP request message consists of the following pieces. The first line is the method or request line, which requests a resource from a server. One example would be get images logo.png. Second are the header fields, which are transmitted after the request line or response line. The header fields are also present in the responses. They define certain parameters for the request, such as authorization, which defines the authentication credentials, from, which defines the email of the user making the request, or host, which defines the domain name of the server and TCP port number on which the server is listening for incoming requests. Check out resource 11.2 if you want more information on that. We have an empty line. This is expected. It's important because it separates the header fields from the message body. And then the last few lines are the message body, which may be structured in several ways. It contains more information about the request and the resource it wishes to manipulate. An HTTP response message consists of the following pieces. We have the status line, the header fields, same as what we saw up here. Again, an empty line, and then the message body. So you can see that both the request and the response have similar, although not identical, structures. The response, I just say that here, the response structure is similar to that of the request, except with the status supplied in place of the request. So we switch out this first line. Instead of being the request, we have the status line. Now we're going to move on to a very important part of this background, and that's the Open API specification. We need to discuss this Open API specification, also known as the Swagger specification. This is a previously used name. This framework, or one could consider it a sub-framework, allows developers to quickly and efficiently create interface files, an important part of a gateway. And these interface files define the functionality of RESTful web services. The Open API specification does not employ any specific language and is compatible with software modules that employ various languages. So let's look at certain characteristics of the Open API specification. First is format. The Open API-based RESTful API description. So this is the source file that we use to actually define the API. We're going to look at that in depth in a couple minutes. It looks a lot like a JSON object. So it uses a JSON object-based structure and must conform to JSON standards. All field names are case sensitive. I know that seems like a random thing to throw in here, but you have to remember that because it has an effect on the way that you code the gateway. Again, check out this resource if you want some more background there. Field types. There are two types of fields, or two basic types of fields. You have fixed fields, which have a statically declared name, and pattern fields, which are dynamically defined and employ a regex pattern. Again, I've seen this so many times written, I've never pronounced it. So regex, I'm not sure. Third, let's talk about the file structure. The Open API specification generally defines the API as a single file, and this is the JSON similar, or the file that looks similar to a JSON object. Developers can choose to divide the file into multiple parts, but we're not going to discuss that here. It's an unnecessary complication for what we're looking at. We're going to assume that we're defining a single Open API description file. Data types. The data types employed are shown in the table below right here. Note that the data type file is also used to indicate that the response type may be a file. That's not shown in the table. Some types are accompanied by a format property, which acts as documentation, instructing developers how to employ that data type. Those without format properties follow the general JSON schema. And so you can see here, really not too many surprises. You have your integer, long, float, double, string, byte, binary. Now down at the bottom you can see there's some interesting types there. You have date, date time, and password. And so these, for the most part, are strings or are defined by the RFC 3339 standard. And you can see here that in the format there's some information that tells us how this will be structured. Specifically for the password, that just tells the UI that the information being put in needs to be obscured. Normally when you put in your password, you just see star, 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 star. You don't see the actual information. Next, we talk about the Swagger root object, or the Open API. You call it sort of the source code, although that's not necessarily the best description. So the root object for Open API for the specification is called the Swagger root object. Note that previously this object was defined in two parts, but we don't do that any longer. We're going to outline some of the more important fields, and we're going to, as you can see in the list down here, I've sort of outlined them as required or not. So if they're not required, I just simply didn't put required. The type, so string, and then the field name itself. Note that the field names are not capitalized, which is just something to be aware of. Now, we're going to talk about some of these components of the root object, and then later on, when we move into our in-depth look at the source code or the root object itself, we're going to see examples of those being implemented. Okay, so first, we have the required string Swagger. This defines the version of Swagger being used. We have the required object info. This provides a metadata description of the Open API or of the root object that we're describing. Again, just a little text description of what it is that we're trying to do. Then we have the string schemes. This is the transfer protocol to be used. Our example uses HTTPS. Then we have the string not required string consumes. This is a list of MIME types that the API can consume or accept. And so there are multiple types. Our API is going to consume a JSON and generate a text /plain. Essentially, it's just saying that we're generating text. Now, there's other types you can see down here. I'm not going to go through every single one, but you can see there's JSON types, etc. Okay, then we have string produces. Again, all these types up here that fall within consumes, they can also be used to define the type of result that we produce. Again, our API that we're going to be building is going to return a text plain type of object. Next, we have the required object paths. This is a really important part. This defines the available paths and operations for the API. Our example provides at least 4 paths that we are going to outline below. This is going to be really important. We need to have a clear understanding of what paths our API gateway is going to accept and where it is going to route those requests to. Next, we have the object definitions. This defines the data types produced and consumed by specific operations. See, that's a little bit different than what we did up above, where we talked about the data types that our gateway is going to produce. It functions almost like defining new class objects in a language like Java. So we have an example right down here, which we're going to show in a second. Instances of these definitions may be used within our API. There are 2 fundamental definitions that this API employs. And when I say fundamental, I mean that it's a root API on which others are based. So we have more than 2 definitions, but 2 I would consider to be the root or base definitions. One is pet. It has a type, object, and 3 properties, including ID, type, and price. So let's take a look at this right here. So we're telling our API, Open API specification that pet is a type object, and it has 3 different properties. It has ID, it has type, and it has price. And all 3 of those parameters are of type string. So you can see how this is somewhat similar to declaring a class object in a language like Java. The other is pet type, which enumerates the types of pets we will consider: dog, cat, fish, bird, etc. And so you can see down here, pet type, it is of type string, and it has the following values, the enumerations: dog, cat, fish, etc. There are other definitions that we're going to see in our example, but I don't consider these to be base definitions because they are based on those two. So for example, pets, which defines an array of pet objects whose definition is provided right here. But we have empty, which returns an empty object. New pet response, which defines a response that contains both a pet object as well as a string message. Now you can see I'm skipping the text here, which talks about the reference location. I feel like when we go through the source code, that would be a better time to bring this up. So I'm going to kind of glance over that for the moment. Then we have new pet, which defines a new pet with an associated price. Next is the not required object parameters. Note that we're still going through our list of components, or let's say the important components of our root object for the open API architecture. So this not required object parameters maps the name to the parameter it defines. For example, the parameter pet ID is the ID of a pet to retrieve. It is a required query parameter of type string. So let's take a look here. So we see we're defining the component parameters. It is then composed of this JSON object right here. We see the name of the parameter is pet ID. It is a path. We have a description, the ID of the pet to retrieve. It is required for certain types of queries, and it is of type string. So this is similar to defining, if we were to draw a parallel to writing code in Java, this is similar to defining a variable type. Next, in our list of components that are important to the API, open API specification, we have the not required object responses. This defines the responses to be used by an operation. For example, the 200 type response describes a successful operation with the headers as defined below. So response, the specific response here is 200, which most of you will recognize as standard for HTTP requests. The description is successful operation. And then here we have headers, which we can include what content that we are returning. Now, I know that much of what we've shown above and here and previously is perhaps not making the most sense right now. And I want to ask you to be patient, because what we're doing is we're building up to looking at the Swagger root object or the Open API root object in detail. When you see down below, we're going to actually go through the individual pieces of this. And so what I'm trying to do right now is sort of prepare you for diving into that code by providing some sort of preview into what components it is that you're going to see. So what I would say is hang tight, keep paying attention, try to take in as much as you can, and when we get down to the source code or the root object itself, I think all of the pieces will come together and it will make a lot more sense. Now note that the root object may also contain custom patterned components like X Amazon API Gateway integration. These objects must begin with X and dash. This indicates to the Open API specification that this is a custom component or field that we have included in our specification. So now we are ready to jump into the example itself. And the first step is going to be to define the objectives and methods. So check out resource 11.02.c if you want some more background here. The first thing we must understand is that this gateway works in conjunction with an existing set of services / microservices at the URL shown here. Our gateway is not going to define any new services, And the objective of this example is to accept 4 types of requests, which are listed below, and route them to the appropriate URIs that the host services or provides. So again, what you have is our existing back end. And so this is already generated and created by AWS. And then we have requests that may be coming in. And we are building an API gateway, which doesn't define what happens to the data in the back end. It simply is able to interpret requests and appropriately route them to the back end. So, what are the 4 different types of requests that we are going to look at? One is going to be return a web description of the project, and this is indicated by the path /get. This request does not forward anything to the service provider, so it essentially stops here and returns an answer. It simply returns a web page describing the objective of the gateway and this project. Next, return a list of all pets. Now, one thing I should say here, I didn't really talk about this. The back end itself, this back end here, is based on a pet, what they call a pet store example. This is one of the examples that's provided by AWS. So in short, what we're doing is sort of maintaining a list of pets for sale, what pets are in stock, what are the prices, what type of pet is it, and I'm sure you kind of got that gist from looking at components like this right here. So I'm not going to go too much into the way that the back end works because that's not really the objective. However, you'll see when we look at these 1, 2, 3, 4 paths that you'll see they correspond to these functionalities or objectives that are relevant to this pet store example. Okay. Next, we return a list of all pets. So this is the second type of request we can see, which is indicated by the path /pets/get. This request forwards to the URI shown right here. So remember we said that the request comes in and the API gateway is going to send it to the back end. So the URI of the back end is http petstore-demo, etc., etc. This request returns a list of all pets contained within this database currently. The third request is create a pet and add it to the record. This is indicated by the path /pet/pets/post. This request forwards to a different URI or slightly different URI, and it creates a new pet and adds it to the database. The last type of request that we're going to look at is returning a single pet's information, which is indicated by the path /pets. Then you have to include the actual ID of the pet that we are looking for, and then /get. This request forwards to the URI shown right here. It retrieves the information for a single pet and returns it as a JSON object. So our main objective here is to take these 1, 2, 3, 4 types of requests and properly perform any translation that's required and route them to our back end. Then whatever response it returns, also give that back to the client. Now we move into step 2 of the example, which asks us to access the REST API gateway and import an example, essentially this pet store example, what we were just talking about. So we considered creating our own version of the pet store example from the ground up. However, we decided against doing this for several reasons. First, we've already covered how to build an API, and so doing that again would be a little bit redundant. Second, the code or the Swagger root object for this example is relatively long, so we figured it would be more effective to spend our time picking apart that object piece by piece, practically line by line, as compared to building similar code from the ground up. So as such, this example is taken directly from the AWS documentation. I want to make that clear. And we are going to follow the steps below to access the example code. We begin by logging into Amazon Web Services and proceeding to the API Gateway service. That leads us to the screenshots we show in 1 second. Accessing the example is pretty straightforward. You log into Amazon Web Services, use the search bar to find the API Gateway service, and then you'll see an array of options, one of which is REST API as we show. You can click on the import button in order to bring up the example, the pet store example that we're looking for, and then you'll see the API code written in the Open API specification that we've been discussing. Now that we have the example in front of us, we can move on to step number 3 of the example, which asks us to review the API gateway root object as defined within the Open API specification. So let's spend some time dividing this code, this source object, into pieces and explaining it. Like many other modules, our objective is to give you the skills you'll need to recreate this functionality as quickly and effectively as possible. As such, we're going to highlight the most important pieces of the code, those that you will most likely need to change in order to adapt this example for your own potential application. This code does provide a solid foundation for the development of your own API gateway. Please check out resource 11.03 right here. A quick note, I'm not always going to specifically talk about these resources. They're shown on your screen. You can see they're highlighted in red. And if you have a question or the desire to know more about a given topic, most probably what we just talked about in the previous sentence, you can check these out. But again, I'm not going to specifically talk about them every time. So we're going to employ a RESTful architectural style. And again, full disclosure, this module is heavily based on the Fish Store API example provided within the AWS documentation. Check out these resources. Now, let's take a look at a visual representation of the API source code, or this Swagger object, what we call the Swagger root object. Okay, so what are we trying to do here? What I've done is I've taken the Swagger root object and broken it up and highlighted the most important pieces as pseudocode. So what we did was I provided some background on the Open API specification. Then what we're going to do is go through this visual overview of the code, and then hopefully those two steps will prepare us to actually look at the code itself, and that is what we're going to do last. I mean, the code is pretty long, so what I'm trying to do is prepare you to jump into that, hopefully by giving you a good enough of an introduction. So let's take a look at the important parts of the Swagger root object. We have the version of Swagger that we're going to be using, 2.0. We have some metadata which is contained within the info field, and then the schemes that we're using. In this case, we're only using HTTPS. Now, this is an important part right here. We define the paths. If you remember previously, we talked about 4 different paths that we are going to be using or defining. We have one that returns the web description, a list of all pets, allows us to add a new pet, and then allows us to retrieve information about a single pet. Now you'll see within the path description, it's here that we actually define within the gateway how these requests are going to be routed to the back end. And we'll see that in a second. Next are the definitions. Again, this is what I compared to sort of like the class objects if we were writing Java code. And we have 5. I've already outlined these. The 2 most basic ones are pet and pet type. And then the other ones, pets, new pet response, and new pet, are all based on those 2. So pets is an array of the pet schema objects. New pet response is a new response that contains a pet object and a message. Pet is the basic definition of the pet for this example. New pet represents, as the name suggests, a new pet with a new price that you can define. And then we have pet type, which enumerates the types of pets our gateway considers. Next, we have the third part, which is a custom component of our API gateway, and it essentially provides information that Amazon Web Services needs in order to properly implement this API gateway using their service. And you can see, we'll talk about this more, we have to define something called the documentation parts. And within there, we are going to provide an alternate definition of our pathways, or the ways in which the requests are going to be routed from the client to the server. We're not going to cover every single piece of this documentation right here. Unfortunately, I'm going to have to refer you to the AWS online documentation in order to learn a little bit more about this. It really would become a module strictly on that if we went down that rabbit's hole too far. So anyway, this though gives you a pretty good understanding of what I would consider to be the four main pieces of the Open API specification, the root object that we're using. We have sort of like a header with some general information. We have the paths, we have the definitions, and then we have some additional information that AWS specifically needs. Next, it's finally time to jump into the code itself. We're not going to discuss every line, but we are going to do a pretty good job. We're going to go through most of them. We will discuss the ones that are most relevant to the structure of the API. We're going to discuss the ones that you will most likely need to change in order to implement your example. We spent significant time properly indenting and separating the API definition into pieces to maximize understanding. Note that the comments are shown in red this time. I normally use gray. But the reason why I did that is because they must be removed from the code before it may be run properly. So this is found in resource 11.07, and this, I think I said in the beginning of the module, is the primary resource for this example. All right, so we define the version of Swagger that we're using. We define some metadata associated with our API gateway. This is your first API with Amazon API Gateway, etc. We define the schemes to be used. And now we get to the second, so this was the first part. Now we get to the second part of our Swagger root object. We define the paths. And again, you can see here, this is all following the basic JSON structure, right? You have a key, and then this key refers to an object which is nested within inside of it, and then it's nested and nested further. So for those of you that are familiar with JSON, JavaScript object notation, this should not be too difficult. If you are not familiar with JavaScript object notation with JSON, I do recommend perhaps you take a little look at some appropriate resource online. Okay, so the first path is going to be /get. And the description tells us it returns an HTML web page containing the API usage information. It consumes a JSON object and produces a text or HTML-based response. The response is defined by this type 200, and nested within it will be the response itself. For each one of these paths, you'll note that we need to define an associated Amazon API Gateway integration object. And so what this does is this defines the responses that are available to it. In this case, we have the default response, which is type 200, and then we have a template right here, which essentially shows the HTML that would be displayed to the user if they should make that request. There's some additional information down here. It essentially defines what to do when you have no appropriate match for this type of request. I'm not going to go too much into this part of the code. Again, we're limited by time and the need to be concise here. Okay, the second path is /pets/get. Now this is the one that returns a list of the pets. So as it says, summary, it tells us we're going to list all pets. It produces a JSON object. Now, note that there are two query parameters that are going to be accepted. They include the type of pet to retrieve as well as the number of pages to return. So when you make this request, you can modify it in two different ways. So the parameters, one is named type, which is essentially going to define what type of pet we want to retrieve. The second one is called page, which is the page number of the results to return. Now, it returns this specific path returns a response with an embedded pets object. Remember, that's the array that we defined in the schema part. We haven't gotten to that part of the specification yet. In other words, it returns a list of pets. And so now I want to focus in on this line for just 1 second right here, because when we define the schema, which is another way of discussing the object type that we're going to return, you'll note here we have $ref, and then it refers to definition / pets. So this right here, this is the location within the Swagger root object where we define pets. And that is the type of response that it is going to be providing. Again, we have our API gateway integration information. But one really important piece is this right here. Now you'll note that the previous request, which returned the web page, you'll note that it does not have this URI field. So if we go back up here within the integration component, you don't see anything that refers to a URI. Now why is that? It's because this doesn't forward to the back end. It just simply returns this right here to the user. However, the second path is going to need to communicate with the back end, and it's here where we perform a very important task of specifying how specifically the request is going to be routed, and it's going to be routed to this URI right here. So this is the main point at which we define the mapping between our client requests and the servers that will actually be handling them, or the microservices that will be handling them. Now we have the third path, or the third type of request that we can see. This one is going to be /pets /post. Now, one thing you'll note here is that this is further indented than some of the others, and the reason for that is because this is going to fall within the pets field, or the pets key. So this is pets /get. This pets propagates all the way down to here, and so down here this is within the pets field, so it's pets /post. Some information about the type of operation, what it consumes, what it produces. And now you'll note in this one, it does consume an object. The previous one did not. Okay, our pets pathway. And the reason for that is because if we're doing a generic search, there's nothing to be passed to it. It returns a JSON object, and then these are the parameters that are going to be accepted. We have essentially just one. We have the new pet object, which is going to be then added to our database. And again, we use the schema, or the custom object, that's defined within this very file further below in the definitions section. So this ref, $ref, is indicating to the Open API specification that we are referring to an object, or what we call a schema, that's defined within this very file. Again, we define the type of response, which is defined as a new pet response, again using that $ref syntax. And then if we go a little bit further down, we'll see again the back end URI to which this command is being routed. So I hope you're getting a lot out of this. I wanted to pause for 1 second because many of you may be saying, well, you're skipping over lots of lines of code. That's intentional. I did go through this with a fine-tooth comb to isolate where it was important to talk and make comments and where it may be better to skip a little bit in order to save some time and not present an overly bloated description of this file. So again, we scroll down a little bit and we will see there is again a URI that indicates how this request is being forwarded. Okay, so I'm going to jump down a little bit. We have some of the other parts of the Amazon Web Services requested information,
But that's all a little bit of a repeat. I want to get down to the fourth path. So the fourth path is pets, pet ID, get. And again, this is probably should be within the brackets to indicate that it's a specific ID that's being supplied. And so similar structure. We have some metadata right here. It generates a JSON object. It's accepting a single parameter, which is the pet ID. And we have a response. All of the responses are based on this 200 structure. The only difference is what is the schema of what we're passing inside of it. This is using the pet object that we've discussed previously. And we have the API integration information. Again, we have the URI to which this value is being passed, and then some additional options. So, and the only reason why I'm scrolling down here is because this is still part of the Amazon Web Services requested information. Much of this you may be able to keep the same. And I should probably highlight that. I'm trying to highlight the pieces that you're most likely to need to change. And so pieces that you may be able to leave the same, especially if you're going to be implementing it using Amazon Web Services, I'm not going to highlight those areas. Okay, so this marks the end of the paths. Now, if you remember, the third part of the Open API root object or Swagger root object that we highlighted in the visualization was the definitions. And so here you can see we define the pets schema or object, the pet response, empty, and then we have new pet and pet type. Now again, I already showed this. So we've already seen, for example, pet. It is of type object, and it has 3 different properties, each of which is defined by a type of string. And so very similar to the way that we define a class object in something like Java. Okay, now the last part. This is the one that I had the most trouble trying to explain. There is a lot going on here. And so this defines the documentation parts to be imported into our API gateway. As you can see, it's another representation of our gateway structure. And so let's take a look here. So we have, version, we have created date, that's all understandable. Now let's jump into the documentation parts. So what you'll see here is that we have locations that correspond to the paths that we have defined previously. So for example, this corresponds to pets, pet ID with the method get. So you can take this get and paste it up there. Same thing down here. You can see we have, for example, this would be the first one, which is /get. This returns the web page. We append that there. Then we have pets, pet ID. Then we have pets get. This is the one that returns a list of all the available pets. And then we have /pets /post, and that allows us to add a new object. So you can draw the lines here, 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 and here. So you can see what we're doing is we're representing our API structure in a way such that Amazon Web Services can understand it. So let's take a little bit of a deeper dive into one of these, and I think perhaps the easiest one will be this one right here. Okay, so the location. In other words, how do we make this request? It's going to be applied or supplied to path pets /pet ID. It is a method, as most of these will be. And we are using the method get. So that way you can see this piece covers all of this right here, okay, from here to here. And then get is appended onto the end. The properties. Tags, we haven't really talked about tags. This is just another way to provide some metadata for our request. And there's a summary here, which is more metadata. But specifically, the most important thing here is that this piece is providing a correlation between what we have written above and what we expect Amazon Web Services to implement. Again, down here, we have pets/get. This matches what we have to the right, and so on. Now, there are some other requests you'll see down here that we're not going to talk about specifically. Path parameters, query parameters. These are certain types of requests that are built into the API or Amazon Web Services API gateway and allow you to retrieve other pieces of information. And so again, you'll see there's several locations that may not be recognizable to you. So there's 4 up top that correspond to the paths we've defined above, and then there's others which are what I would consider to be sort of like overhead or other requirements of the API gateway. And so that marks the end of, misspelled that, marks the end of our Swagger root object. Now, did we go through every line? No. But I think between the background, the visualization, and this relatively robust review of the code of the Swagger root object, we've provided you a good starting point from which to begin working with these API gateways using the Open API specification. The last step here, step number 4, is going to be to import, execute, and test our example. So the good thing is that in order to test your example, you don't actually have to do anything to the code shown up here. The example is already ready and you can run it within AWS. And that provides you a unique opportunity because now what you can do is you can begin playing around with different pieces of it, changing certain parts in order to manipulate the functionality and see if it works or not. If it doesn't work, you have to go back to the base definition and then perhaps try a different type of change. So now that we've accessed the API source code, or again, the Swagger root object, and improved our understanding of its structure and syntax, let's go ahead and run it. After you hit the import button, if you remember the screenshot from way above, in the bottom right-hand part of that screen, the structure of the API will be shown in the AWS Web Console as right here. So this is nice because this visual representation lets you know whether your intended API structure is actually what AWS is recognizing. So you see we have get, we have pets, this returns the list of pets, and then you have everything else. If you were to scroll down, you would see the others. Now, once we have this up and running, we want to go ahead, go into Actions, then go and hit Deploy API, and that will make it visible online. We can go ahead and give it a stage name, description, deployment description. I just used dummy variables, test. And then that will go ahead and give you the URL that you can use. So before, we clearly outlined the request available to clients. There are get and post type methods. The get methods may be accessed via any browser because it doesn't require any data to be passed. The URL is generated to reflect the structure of the API as shown above. For example, the first element of the pet store may be accessed using this URL. So this piece of it right here, up until right here, okay, is just simply taken from this and moved downward. And then now what you see is we're going to use our existing paths and append it to the end in order to get the desired response. So let's say, for example, we wanted to get, again, the first element of the pets list. We do /pets/1. Note that you don't have to put get after, that's not GI, get. You don't have to put get afterwards. When you're accessing it through the browser, it's going to be implied that it's a get type response. So you can see here, I copied and pasted this into a browser. So this should be another window separate from your AWS window. It doesn't have to, or it shouldn't be that same window. And it provides us the information that we're looking for as a JSON object. Now, it can be potentially more effective to test an API using curl commands. We've talked about curl commands previously. In the figure below, or in the lines below, we ran the curl commands via Cygwin, spelled that wrong. However, newer versions of the Windows command prompt allow us to run these curl commands. You can check these out in resource 11.08. So what we're doing is we're running two different curl commands. Curl get, we include the URL, and then the path is appended to the end. So this right here would do what? This would return a list of all pets. And this right here would return just the first element. Now, the browser cannot be used to perform the post elements. However, the curl commands can. So you can see here we have curl -d, which indicates that there's data to be passed to it. And so we are going to be creating a new pet, which is type hawk, and it has a price of $9,999. There's a couple other pieces of information. We need to include a header telling the request, or indicating what type of content is included in the request. It is a JSON object. As you can see, it's formatted right there. And we are going to be posting it to the location shown. So using curl commands, we can perform both the get and the post types of request. And the results of the commands are shown right here. So you can see here where I called both, or made both of the requests. And you can see this one gave us a list of the pets, and this one, because again here we indicated which index to retrieve, it just gave us one pet. And then if you scroll to the right, you can see this is the example of the post. I just copied and pasted that same command, and you can see a response telling us success, that the post method was successfully implemented. Now again, I used the Cygwin application for this. However, that's not required. You can now do this in the Windows command prompt.
So that marks the end of this module on the Java API Gateway for Amazon Web Services. This was a really interesting module. It was a long one, I know, pretty close to an hour long, but I think we went through a lot. We talked about some background on API gateways. We went into a pretty in-depth discussion on the Open API specification, and then we went through 2 or 3 different descriptions. We had the visual description as well as the code description, and then some background. So 2 or 3 different descriptions of our API gateway. Now, like I've said several times, the goal of this class is not to provide a really lengthy discussion with all the theory behind certain topics. We want to give you the core information that's required to take this example, manipulate it as needed, and use it for your own purposes. And I think we did a pretty good job of that here. So if you need more information on the API gateway, I encourage you to check out some of the resources, but I think this should be a very good starting point for those of you that are looking to use API gateways in order to better organize your microservices or combine existing or pieces of existing APIs together.